So good day, my dear students. For today's video, we're going to talk about the principle of mathematical induction. So first, what is principle of mathematical induction? So by definition po, principle of mathematical induction is a way of establishing that a given statement, usually in a form of equation and inequalities, hold for any natural numbers. So kapag sinabi po nating equation, meron po siyang equality symbol. So kapag sinabi naman po nating inequalities, meron po tayong an equal sign, meron po tayong greater than, meron po tayong less than, greater than or equal, and less than or equal. Ngayon po, ang ginagawa po kasi nitong principle of mathematical induction is to prove po that a given statement on the left side is the same as the statement or the mathematical statement on the right side. So later po, mas maiintindihan po natin yan kapag nagkaroon na po tayo ng mga examples. Now, the principle of mathematical induction has 3 steps. So the first step is to show that the statement holds for n is equal to 1. Number 2, assume that the statement is true for some natural number k. And show that the statement holds for n is equal to k plus 1. Kaya po dito po sa steps natin, kung makikita nyo, if true po siya sa number 1, possibly po na true siya sa iba pa pong number na kasunod kay 1. So that is why we assume that the statement is true for k. So this step number 2 is also known as the hypothesis of induction. Sa step 1 po, kapag na-prove natin na true siya for n is equal to 1, possibly na true siya sa mga susunod na number na k, na kasunod po nitong 1. Then, kapag meron na po tayo nitong dalawa, pwede na rin po nating ma-prove na sa iba pang susunod na numbers ay true din po siya kapag napatunayan natin ito pong step number 3. So without further ado, let's proceed now to our first example. So for our example number 1, the summation of I as I starts from 1 to n is equal to n times the quantity n plus 1 all over 2. Ngayon po, kailangan i-prove natin daw po ito na true siya sa lahat ng natural numbers. For step 1, show that the statement holds for n is equal to 1. Meaning to say, lahat po ng n, papalitan lang po natin ng 1 at kapag nag-true po siya both sides, ibig sabihin, natapos na po natin ang step number 1. So we have the summation of I as I starts from 1 to n is equal to n times n plus 1 all over 2. Ngayon po, ang gagawin daw po natin, lahat ng n is papalitan natin ng 1. So we have the summation of I as I starts from 1 to 1 is equal to 1 times 1 plus 1 all over 2. Ngayon po, sabi dito, mag-i-start daw po tayo kay 1 hanggang kay 1. So ano po ang summation niya? 1 lang po yan. So we have 1 times 1 plus 1, that is 2, all over 2. So that is 2 times 1, that is 2, divided by 2, that is 1 ulit. So that is true. So na-prove po natin na for step number 1, n holds for n is equal to 1. So nag-true po siya. So proceed po tayo kay step 2. In step 2, it is said that we should assume that the statement is true for some natural number k. So dito po, wala naman po tayong gagawin dito masyado. Papalitan lang po natin ng k yung mga n. So we have I, the summation of I, as I starts from 1 to k, is equal to, lahat po ng n gagawin natin k. So I have k times k plus 1 all over 2. So this is what we call the hypothesis of induction. So now naman po, let's proceed to our step number 3. So ito, wala muna po tayong gagalawin dyan kasi gagamitin po natin siya as we prove for step number 3. So for our step number 3, show that the statement holds for n is equal to k plus 1. Kung dito po, lahat ng n pinalitan natin ng k, so step number 3 naman po, papalitan natin lahat ng n ng k plus 1. So for our step number 3, we need to change all of the n sa k plus 1. So we have the summation of I from 1 to k plus 1 is equal to k plus 1 times n, k plus 1 po ulit. Plus, dahil meron po siyang another 1 dito, wag po natin kakalimutan yan, all over 2. So we have now k plus 1 times k plus 2 all over 2. Ngayon po, di ba po ito, from 1 daw po to k plus 1, ibig sabihin po, ang summation na to is also equal to 1 plus 2 plus 3 kasi po start daw po sa 1 plus hanggang maabot natin yung k. Pero hanggang k plus 1 pa po siya. Kaya mag-a-add tayo dito ng k plus 1. So now, as you can see, ito pong part na to is actually equal to our summation of I as I starts from 1 to k. At ito po is equal po dito, di ba po? Ito po yung sinasabi kung gagamitin natin ang step number 2 para i-prove yung step number 3. So, ibig sabihin, kaya natin itong maririte into k times k plus 1 all over 2 plus, wag pong kalilimutan na meron pa po tayo ditong k plus 1. So, ngayon po, gayahin lang po natin yung nasa right side all over 2. Ngayon po, ito, dahil hindi po siya fraction, ma-add lang po natin ang dalawang fractions if gagawin po din natin itong similar fraction. So, pwede natin siyang i-multiply by 2 para makancel lang siya. Ito po yung matitira. So, we have here k times k plus 1 plus 2 times k plus 1 is equal to k plus 1 times k plus 2 all over 2. Ngayon po, ito pong k plus 1 and k plus 1 are the same lang naman po. So, ibig sabihin, pwede natin siyang i-factor out. At ito pong mga nasa labas, pwede natin siyang pagsamahin. So, remember po yung lesson natin nung grade 8 po about factoring. So, yun, may apply po natin siya dito. So, we have k plus 2 times k plus 1 all over 2 is equal to k plus 1 times k plus 2 all over 2. So kung mapapansin nyo, may k plus 1 dito, may k plus 1 dito, may k plus 2 dito, may k plus 2 din po dito, at may denominator silang 2. So therefore, na-prove po natin na this is true. So ano pong ibig sabihin yan? Ibig sabihin po, ito pong statement na ito is true for all natural numbers. For example, number 2, we have here the summation of I squared from 1 to n is equal to n times n plus 1 times the quantity 2n plus 1 all over 6. So first things first, we need to prove that the statement holds for n plus 1. Dahil kapag naging totoo siya sa 1 pa lang, posibleng totoo siya sa mga susunod pa nitong numbers. So first, let's change n to 1. So we have here step number 1 is equal to the summation of I squared from I is equal to 1 is equal to 1 times 1 plus 1 times 2 times 1 plus 1 all over 6. So that will give us C1 daw po I po siya. So, I squared, dahil mag-stop din po siya kay I, is equal to 1 times 1 plus 1, that is 2, times 2 times 1, that is 2, plus 1, that is 3, all over 6. So, that will give us 1 is equal to 1 times 2, that is 2, times 3, that is 6. 6 divided by 6 is equal to 1. So kung makikita nyo, nag-true po siya sa step number 1. So let us proceed now to step number 2. We need to assume that the statement is true for some natural number k. So ang gagawin po natin dito is kung sa step number 1 po, papalitan natin lahat ng n ng 1. Sa step number 2 po, papalitan po natin lahat ng n ng k. So we have here the summation of I squared as I goes from 1 to k is equal to k times k plus 1 times 2k plus 1 all over 6. Ngayon po, sa ating step number 3, we need to prove naman po that the statement is true for n is equal to k plus 1. So, ang ibig sabihin lang po nito, lahat po ng nakikita nating n, papalitan po natin ng k plus 1. So, step number 3. So, we have here the summation of I squared from 1 to k plus 1 is equal to k plus 1 times k plus 1 plus 1. Bakit po may another plus 1? Kasi po dito may plus 1 pa po siya. Ang pinalitan lang po natin ng k plus 1, ito pong si n. Times 2 times the quantity k plus 1 plus 1. Ngayon po, pwede po natin siyang divide both sides by 6. Ngayon po, pwede po natin siyang i-simplify muna. So that will give us k plus 1 times k plus 2 because 1 plus 1 is 2. Now, let's distribute po 2 times k, that is 2k, plus 2 times 1, that is 2. But, meron pa po ditong plus 1, so that will give us 3 all over 6. So, ito po, pwede natin siyang ma-rewrite into 1 squared plus 2 squared plus 3 squared hanggang po makarating kay k squared plus the quantity k plus 1 squared. Bakit po k plus 1? Kasi yun po yung kailangan na stop daw po nitong summation na ito, k plus 1 squared. So ito pong part na to, katulad po ng example natin kanina, pwede po siyang ma-rewrite dito po using our step number 2. So ito pwede po siya natin gawin na k times k plus 1 times 2k plus 1 all over 6 plus k plus 1 squared. So ngayon po, copy lang po natin to para po makita natin mamaya kung mag-i-equal po sila. So ito po, kailangan po natin siyang gawin into similar fraction. So ang gagawin lang po natin is to multiply this by 6 over 6. So magiging po siyang k times k plus 1 times 2k plus 1 all over 6 plus 6k plus 1 squared all over 6. So kapag kinancel po natin itong dalawang to, ito lang naman po yung kalalabasan niya. So copy po natin yun para mamaya po makita talaga natin na equal sila. So now, pwede po natin silang ma-combine like terms. So we have here 6k times k plus 1 times 2k plus 1 plus 6k plus 1 squared is equal to k plus 1 times k plus 2 times 2k plus 3 all over 6. So kung makikita po natin, dito sa part na to, parehas po silang may k plus 1. So pwede natin siyang i-factor out first, k plus 1 times the quantity k. Pag inilabas natin si k plus 1, matatanggal na po siya dito. Kaya magiging 2k plus 1 na lang po siya plus 6k plus 1. Bakit po naging ganon? Kasi po, tinanggal lang po natin yung isang k plus 1. So, since dalawa po sila, kapag inilabas natin, nandito po yung isang k plus 1, nandito po yung pangalawang k plus 1. Divide both sides natin po siya by 6. So, we have here k plus 1 times k plus 2 times 2k plus 3 all over 6. Ngayon po, pwede natin siyang i-distribute po. So we have here k plus 1 times the quantity k times 2k, that is 2k squared. So k times 1, that is k lang po, plus k, plus 6 times k, that is 6k, plus 6 times 1, that is 6. All over 6 is equal to k plus 1 times k plus 2 times 2k plus 3 all over 6. Yan po, muli natin. Ngayon po, ito po, pwede natin siyang mai-simplify as 2k. So, lagyan lang po natin ng line para hindi po magulo. So, ito po, pwede natin siyang mai-simplify as 7k. So, we have here k plus 1 times 2k squared plus 7k plus 6 all over 6 is also equal to k plus 1 times k plus 2 times 2k plus 3 all over 6. So ito po, pwede po natin siyang ma-factor out. So we have here k plus 1 times 2k, close parentheses, times another k times close parentheses all over 6. So since lahat po sila plus po, so ibig sabihin addition symbol po or addition operation din po ang gagamitin natin sa dalawa po. Then mag-iisip po tayo ng dalawang numbers na kapag pinag-multiply po natin is 6 at yung dalawang numbers po yun is 2 and 3 because 2 times 3 that is equal to 6. Pero hindi po natin alam kung alin po dito sa dalawang to ang ilalagay natin yung 3 at alin naman po sa dalawang to ang ilalagay natin ay 2. So try po natin na ilagay dito ang 3 and ito naman po ay ilagay natin 2. So check po natin kung tama po yung order. So we have here 3k, 3 times k, that is 3k, and 2k times 2, that is 4k. So 4k plus 3k, that is 7k, which is equal po dito. So ibig sabihin po, tama po yung order natin. So equal po uli siya sa k plus 1 times k plus 2 times 2k plus 3 all over 6. Ngayon po, kung makikita nyo, meron po tayong k plus 1 dito, may k plus 1 din po dito, meron po tayong k plus 2 dito, may k plus 2 dito, at meron din po tayong 2k plus 3 dito, and 2k plus 3 dito. And of course, meron po tayong denominator both na 6. So, na-prove na po natin na this mathematical statement holds true for all natural numbers. For our example 3 and 4, I'll see you in my next video. Thank you for watching. Don't forget to subscribe.